Hi, hi everyone. The good news is I probably won't take up the 20 minutes. So anyone who wants to go to the pub will get there a little bit quicker. Okay, so my name's Darren Prehaye. I'm a senior solutions architect at a company called Digital Catapult. And we basically, our remit is we're one of a set of catapults. There's high value manufacturing and all sorts of others. But basically, we work with the government to drive innovation in the UK. That's our remit. So what am I going to talk to you about? Digital security by design is actually a program that we're deeply involved with. So what is digital security by design? Well, it's a government-backed initiative to basically help us in this UK as us basically become more resilient in terms of digital security. And as part of that, there's basically the focus of this program is two technologies called Morello and CHERI. Some may have heard of it. CHERI capability hardware enhanced risk instruction, and that's technology developed by SRI in Cambridge. And then you've got Morello, which is a ARMS prototype, effectively a chip that works with that technology to basically tackle some of the issues that we have with memory safe languages, C, C++ being those. So these are kind of the organizations that are involved. A lot of you may not have heard of this, but it is at a kind of a low TRL level, TRL being technical readiness level. And so it's still in development, but there has been a lot of work with the technology it's been funded by DARPA and Cambridge and ARM are really working hard on this, as are a lot of the names that you see here. They all have different reasons, obviously a lot of commercial, but they have different stakes in terms of the technology and what they're doing. So what is CHERI? Okay, so CHERI is CPU technology to mitigate software security vulnerabilities. I mean, you can read what it says here, but effectively it's additional capabilities to pointers. So instead of a pointer, I mean, some call it a fat pointer. I think it's about 128 bits, but it effectively provides more security than your standard pointer. And there's an additional, it's the stack up. So the CPU is adapted in terms of system on chip, and there's new primitives added. And so you effectively are now exploiting new, I guess, technology. First of all, I'm going to say this just before I go further. I'm a solutions architect. I'm not a programmer. So the deepness that you may expect, I'll be able to point you to the right places, but I'm not a programmer. But yeah, effectively, I do know about out of bounds issues and stuff like that. I think most people do. And this is about mitigating that. So we work. The premise, I guess, is that for whenever in a day we've had CPUs, and the development of those has always been more about performance and so forth. But the fundamental architecture hasn't really changed, although a lot has since the CPU design in terms of society, the internet, this, that, and the other. All of those things, that means that security mitigation has changed a lot over the years. And I guess what this is about is going fundamentally back towards, well, actually, we need to think about security by design, as in the chip, system on chip, and think about how we can kind of mitigate and work towards preventing some of those issues that we currently have in terms of memory safe languages or memory unsafe languages, I should say. So in terms of this is basically explaining the stack, what And this is the dark, so the more bolder bits are stuff that Cambridge is working on. So they the Commute and CHERI with Morello, and the risk, the mention of risk 5 is that there are people doing stuff with risk 5. Obviously it's open source, so people are doing what they do with open source stuff, I guess. But the up the stack and what we sort of have been working with, and say working with, as in we work with ARM and we work with Cambridge, and we're close to what they're doing in terms of development, is the compiler tool chain. They've got LLVM, and I know that a lot of people, when we're working with cohorts, and Gavin will explain what I'm talking about when I say cohorts, ask about GCC and when there's going to be stuff for that, because I know a lot of C people, that's their focus. But effectively, what ARM has done is, in terms of our OS, they have taken free BSD and they've converted that to what they call CHERI BSD, which is effectively a version of FreeBSD that has all of those new primitives that are fed up from the instruction set architecture and the registry change in the chip. And that allows this, basically, that programming, which in a more secure way, because you're now, instead of using a normal pointer, as I said, we're using something called a capability, which effectively restricts how you access memory. So this basically, this slide talks to the stack and what's happening here and what's developing. So at the moment, there's a lot of development at application. There's a lot of porting that needs to happen. This is very, very new. So there's a whole ecosystem that's trying to be built. There are also stuff happening in terms of development. So I know ARM are looking at Linux, specifically Debian as a distro, and there's work going on there in terms of developing that. There's stuff with Yocto as well. There's stuff with, I'm just trying to remember, just different OSs in terms of development. They're at different stages. I think the most developed is CHERI BSD. There's a lot more support there, and there's a lot more applications and being built for that. That's just at the moment. So that's the hardware stack. Now this slide, the reason I kind of wanted to discuss this slide, this is a study. So this happened, and effectively the key thing I wanted to really discuss on here is the lines of code, how much you actually have to, how easy it is to port, how much modification you would need to make to something that, is what we, I guess, call standard C, C++, to what we'd call CHERI C++. And there's, it's not a lot in the scheme of things in terms of as a percentage. And one of the reasons I'm discussing that is because I went to an open source, I can't remember the title of it. I guess some people here might have gone to it at the, was it Queen Elizabeth?
State of Open Conference.
There you go, State of Open Conference. And what was interesting was there was a speaker there from the White House, and she was saying, well, look, the US, they recognize that, and this is a major issue in terms of memory safe hacking. It's about 70% of the hacks that we know, and so they were talking about they're as a program, they're looking at pushing new developments to memory safe languages such as Rust, and trying to create programs that allow people to convert their non-memory safe language, so C to Rust or that type of thing. And what I really wanted to say is that, you know, some of the stuff that we're working on and we're seeing is that it would probably be, in terms of refactoring codes, it seems like a hard push. It would be hard work to do that, given the sort of figures we're getting in terms of actually trying to convert code, you know, from or port code to CHERI. So that's really kind of what I wanted to, why I showed this. Just the conversation is, yeah, there's two ways to go to this. Rust is, or memory safe languages are you need those, and it would be useful to say, okay, as a strategy, we have two routes. You have the memory safe language, and you know, those that are starting new projects and so forth. And then you've got ways of thinking about how do you convert legacy code the easiest way towards something that's safe. And that's where we talk about, you know, porting to something like Morello. This is basically information that we pass on how you can experiment with CHERI. There's a lot of information about it, and there's places that you can look and start. You know, if you're really interested in messing about with it and understanding a bit more. This is, so Gavin's going to talk about our actual program. So we have an access program to the technology, and effectively, this is kind of like what we have. This is what we give out. This is the board. It's a demonstrator. So yeah, it looks like a normal PC, but obviously it's kind of a representation. It's got ARMS chip in there, and you can, you know, build your OS, boot up, and start playing about and doing stuff on there. And I guess when you talk, because I won't take your, but when you talk, maybe you can kind of give you examples of people that have done stuff, not deeply, but just we've got cohorts that use the board, and so this is effectively what it looks like. I think that's it on my on my thing. One point I wanted to actually say is that I didn't say, and it was probably up on there, is as well as memory safety in terms of there's the capabilities and what I call the fat pointer. There's also compartmentalization models that have been developed. And by that, what I mean is that they're less evolved at the moment, but with the technology, there's an idea of sandboxing processes. So it's more mitigation. So it's more saying, right, okay, I am going to reduce the attack surface. And there are different models, as in people who, you've got code, you're bringing in libraries, and those libraries that you're bringing into are being compartmentalized, so that they're coming from a possibly unsafe source. They're coming into your code, and you know, the model itself will basically create a space for those libraries that's it can't do any more damage outside of that space. I can't say much more than that. I can, though, when I say I can't say much more than that, because the technology is quite deeper than I can go into, but I can always provide information that can give you a lot more information on that and point you to the right places and that type of thing. I think that's it. Yeah, I'll hand over to Gavin. I guess after, I mean, I know I've been slightly vague, I guess, compared to what you usually hear, but I can try and answer any questions that I think I can. And if not, I can definitely take questions. I can, whoops, sorry. Yeah. I can actually take questions that, you know, and take them to the right forum. So over to Gavin.
Thank you. Yeah, I'm well aware that I'm the last thing standing between you guys and a fresh pint, so I will try and be quick. Darren's given a very quick overview about the technology. I'm going to speak very quickly about how you guys can get your hands on it. So as he said, we're running a program basically in collaboration with ARM, UKRI, University of Cambridge, to give people working with C, C++ access to join our program, which is a 6-month program where they get access to the Morello board, they get access to the CHERI BSD full stack. You can keep the board after the program, and various touch points with technical support from people. And a nice one at the bottom there, £15,000 of funding to help you experiment with this prototype technology, find out what it can do, what it currently can't do. We're looking really for people to test this prototype technology in the kind of safety critical, national kind of critical infrastructure sectors, areas that if there are problems, it's going to be a big headache for absolutely everyone. Areas that have problems currently with kind of memory safety violations and things like that, that this technology could try and mitigate. As mentioned, this technology is still early days. It is still a prototype. And part of the reason that we're engaged in this program with ARM and the University of Cambridge is to try and help bring this technology up the TRL level quicker, to bring it to market quicker. And one of the things that you would be kind of getting access to would be to be part of that journey. So giving your feedback to the developers, what currently works well, what doesn't, your ideas, your feedback in terms of what they could improve going forward. And hopefully, as it says, kind of be part of the journey of influencing the design of future computer systems. There's a couple of different pathways through the program that we're offering. I'm not going to go into this in very much detail because you can see it up here. But it's available for kind of UK-based kind of companies and UK-based developers at the moment. ARM doesn't want to let their new technology go too far afield before it's commercially available. But as I say, there is availability for funding, a lot of hands-on support, and to keep the board afterwards. So hopefully that's quite a nice offer. There is an application process. If you go to the website that we have at dsbd.tech, there's a lot more information about how to get involved. And basically the application process would be outlining the area of study that you would want to look into. So what kind of use case would you want to put this technology to? What kind of vulnerabilities do you think you'd like to test to see whether it can help mitigate? Whether that's something directly relevant to your business or whether that's something directly relevant to your own personal areas of interest. Either way is absolutely fine. We're just looking for people that are keen to try and get involved with new technology that use C and C++ coding languages, that have some ideas around current issues that might exist with what they're doing. How could these new technologies, the Morello board and CHERI BSD, be put to try and solve some of them? And just to give a very, very quick flavour about what some of the current cohort members have been able to do. So a lot of them have had their own applications. They've been developing code throughout their entire career, and the company they're working with, they do kind of deliver products and code and things on a regular basis. And despite all of that, they've been able to find as yet unidentified vulnerabilities, memory safety vulnerabilities in their own code through running it through the CHERI compiler and kind of getting it actually executed on the Morello board. And as Darren said, there's ways that the kind of compiler can alert you, A, to the memory safety issues, but also B, will give you indications of how to solve those problems. So rather than you scratching your head and racking your brains to think about how can we solve these things, the new compiler will kind of direct you to ways to fill those gaps. It will not let things that are memory unsafe pass, and it will point you to various solutions. And as Darren mentioned, there's a couple of companies that have just started getting involved with the kind of very, very early experimental phase of something called compartmentalization, where the system will allow you to kind of break down the application, the processes of an application into different chunks, sandbox each of the chunks in a way that they still connect with one another. But if any area of that application is compromised in any way, none of the negative aspects will flow out into the rest of the process. They'll be kind of contained and sealed off to offer a bit more protection. If you think that potentially sounds something that you might be interested in looking into to see how these can connect with C and C++ languages and what benefits they might be able to give, we are doing an open call at the moment to try and find people that might be keen to get involved. Goes on until the 26th of March and would start sometime in mid to late May. and there's a bit more information that can be found on the website. So that was probably a very, very quick whistle-stop tour, but I know that beer is waiting, and that's a hell of a lot more important than what I've just been saying to you. So thank you very much. If you've got any questions, please let us know. If not, come and find us, and I'm sure we'll have some answers to give.
Yes. Years and years ago, I was involved with doing this in software rather than hardware. And one of the problems when you switch on pointer checking is you get lots of errors in code that you didn't write from the library. And so you end up debugging other people's code, other people's libraries. It's somebody going to, for instance, the GNU or the GNU C library and the C++ libraries and all the other support libraries. Is somebody going to invest in fixing the problems in those so that I and other people can concentrate on the problems in their code rather than having to debug other people's library code?
So I'll let Darren say something after myself. One thing I will say, though, is that a lot of the code that kind of has to get run on this obviously needs to get ported in and then kind of recompiled for the system. And I know that the University of Cambridge is playing quite an active role in kind of making sure that all of that is correct and up to date.
Yeah, I know some of the people there, yeah.
Yeah. So they are working on that. The only other thing that I would say is that one of the features of kind of the compartmentalization model is that you can kind of throw into one of these sandboxes third-party untrusted software. So if you did need to run it before all of that checking had been done, you could put it in there, for example, run it within your application, kind of safely in the knowledge that it's kind of walled off if anything wasn't entirely ready to go, or there were some vulnerabilities that you didn't have time to kind of check through or had been missed by the developers on their side. That would at least offer you some protection rather than kind of spilling out and kind of ruining the whole system. But Darren, I'll let you add in anything there.
Yeah, not a lot more to add other than to say what we haven't discussed as well, because it's really fast what we're talking about and there's a lot to it, is there are different modes of compilation. So there's something called hybrid mode, which doesn't necessarily enforce the change. It just really highlights. So what we've had is certain people looking and saying, I've gone through the compiler. I've got all these messages. I mean, I can run my code, but it's just saying that it's unsafe. So you're kind of in a situation where you may pick up code that's not safe. It doesn't mean you can't run it. It just means that you're now aware of it. Versus when using another compiler switch, which is full capability, that just says, all right, this isn't safe. You can't run it. So there's that kind of aspect to it as well in terms of, I guess, the fact that, yeah, okay, you've got all these libraries. You can't be responsible for fixing everybody's libraries in the sense of, I can't expect anyone, like, you know, it's on anybody to go out and, as in Cambridge, to fix everybody's library. But what I will say is that it's something that you could do incrementally based on the fact that you now know this library is an issue as a hybrid, or it's something that you kind of think, right, okay, I fix it. But in terms of doing that, you're, I guess, contributing to well, I guess it becomes complex depending on where you compile it. But you're contributing to an ecosystem that becomes creating things that other people can use later on.
Thank you. Hi, sorry. My question is, like, I'm a bit lost. Is this hardware as sans that people have been talking about?
Well, it's both, because effectively what we're saying is that the hardware, in terms of the CPU or system on chip, has been, let's say, created with extra features that can be now used further up the stack. Yeah, so in terms of when we think about pointers and stuff, in the end, it's a conversation with the CPU that all the way up the stack. And so what we're saying is that in order for that what we're calling a capability to be a thing of meaning, it needs to be recognized all the way down. So it's kind of both.
Sorry, maybe different. What kind of error can it catch?
Error?
Yeah.
Well, we're talking about the fact that most of our memory safe issues are about exploitation of pointers, and it prevents it. Yeah, without going into the deep details of that, I mean, one of the things it talks about is it's not exactly permissions on pointers and permissions on access to memory, but it's not far from that. So you can't just use a pointer in the same way that you use it currently. You can't just access memory in the same way that you can, which means that you can't write to memory without permission. You can't access and read from memory without permission. It's basically closing the door of the pointer exploitation that we have now and the way that memory is accessed.
All right, thank you.
Hello.
Hi. Yeah, real quick question.
Yeah, hi. Yeah. Sorry about that. My question was about my understanding is what you're doing, you are concentrating on memory issues in terms of allocation or that sort of thing,
Yeah,
right?
allocation,
Yeah, okay, yeah. Cool. So Rust solves that problem. So does modern C++. There is one problem which Rust does solve and modern C++ doesn't. That's a concurrent access. You know, Rust, those borrowed things, borrowed references, which we don't have in C++. Have you got any thoughts about this concurrent access potential vulnerabilities? That's my question.
What, in Rust?
No, in your this thingy you're building.
Concurrent access? No. I mean, I'll tell you this now. I'm not the person to answer that question. I'm pretty sure that the brains at Cambridge and the people at ARM have and can give you an answer to your question. What I'm saying to you is that, and what I've said at the beginning is, I'm a solutions architect, and to a level, my role is really about evangelizing this technology and trying to we actually wanted to get somebody from Cambridge here to do it justice, but we couldn't. But my role here is more about evangelizing that technology. But what I will say to you is this: if you do need that question answered, if it's really important to you to be answered, I'll take it, and if you give me your email address or information, I can come back to you on that.
To be honest, it's not that important for me. I'm just curious if you have thought about that side of things.
Okay.
So just make a note.
Can I answer this question? You're asking me if I've thought about it. I'm not at Cambridge and I'm not working on the technology, so I haven't thought about anything like that. That isn't what I'm doing. I'm not developing the technology. So that conversation, that's what I'm saying. That conversation is to somebody who's actually working on the technology and developing it.